All right, so this is section 10.2, arithmetic sequences and series. So we'll use some of the things that were in section 1 in this section, but these we're going to, some of those sequences were kind of generic. They didn't really fall into a category. It was maybe a pattern, but not a pattern that you could do the exact same thing each time. So maybe it was that you're squaring your terms every time. In this case, now we're going to have terms where we are adding or subtracting the same thing each time. So, for example, here the first vocab word here says arithmetic sequence. This is a sequence in which terms are found by adding a common difference. Common difference, and that difference is called D. Now, it is always adding. If it looks like you're subtracting, then you're actually adding a negative, but it is always adding. So, for example, this would be a set of numbers here, 2, 7, 12, 17. The fancy brackets there just mean that this is a set of numbers that go together, and obviously we're adding the same thing each time. So we're adding 5. 5 would be my D. Now, recursive form of a sequence, this is not one I'm going to have you write, but you should be able to use, and this was in section 10.1. But this is going to be where they start off giving you a number. So let's say that a sub 1 is 5. Then to find the next term, you're going to plug in the previous term and then add some constant D. So we'll look at how to do one of those here in a little bit. The explicit form, whenever you're asked to write an equation for an arithmetic sequence, this is the one that we're going to use. And that's a sub n is equal to a sub 1 plus n minus 1 times d. For some constant d, and for every n is greater than or equal to 1. N is the number of the term that you want, so obviously you wouldn't be finding anything less than 1. So, determine whether the sequence is below or arithmetic and find their common difference. I don't necessarily need you to show me any work for this, but determine whether they're arithmetic, find the common difference. Okay, so looking at the first one, does it appear that I'm adding the same thing each time? To go from 7 to 3, that looks like I'm adding a negative 4. Does that pattern continue? Yes. So is it arithmetic? Yes. And common difference would be negative 4. If you say 4, that's wrong. I'd probably give you partial credit, but it is a negative 4. Okay. Now, looking at the next one here, because these are decimals, this is not quite as obvious. Sometimes you can look a little further down. So like right here, if I were going to be adding the same thing, it would be a 0.5. Then go back and look to see, am I adding the same thing here and here and here and here? Yes. So your D is 0.5, positive. Now, I'm not going to really give you one where you're adding the same thing 3 times, then the 4th time it's something different. You would really notice it right off the bat. Okay. Now, the last one, pretty obvious, I think, to see that I'm adding a 1 on the bottom each time. But that's not an arithmetic sequence because I have to add something to this number to get the 1/3. And what that would be is not going to be the same thing I would add to 1/3 to get a 1/4. So this is a pattern, and it's a pattern that I could write some kind of a formula for, but it's not an arithmetic pattern because I'm not adding the exact same thing each time. So no. Another really common pattern is just to have, let's say that we have a 2 plus 5, and then we get 7, and then now we add 7 in the 2. And actually, I think that was presented to you as the Fibonacci sequence in a way. Now, mine wasn't the actual Fibonacci sequence, but that same kind of thing where you're adding the number before. Yes, that's a pattern, but it's not the exact same thing. Sometimes you'll also see a plus 2, a plus 3, a plus 4, a plus 5, but again, it's not the exact same thing. Okay. All right. So next, we're going to find the nth term of the arithmetic sequence and then find the 20th term. So when it says to find the nth term, that means I want to write the equation. Now, find the 20th term. You could look at this right now and figure out what you're adding each time and then go ahead and keep adding and adding and adding until you get the 20th term. I'm not going to want you to do that. I'm going to want you to use the formula to do that. And it'll be worded that way on your test. Sometimes on this test, people run out of time because they are literally trying to add till they get all the way to the 20th term, and that is not what I'm intending for you to do. Okay, so in this case, in order to write that nth term, I'm using the formula up above. I'm going to go ahead and write it again here. Okay, so to do that, I need to fill in two things here. I need to fill in my first term, and I need to fill in my common difference. So that's going to be a sub n is equal to, okay, my first term, I'm going to write that out to the side here. My first term is -4. It's the first one in the sequence there. And my common difference, I'm adding 7 each time. Okay, sorry about that. I had to answer the phone. So now we're just going to plug those numbers in here. So a sub 1 is -4 plus n minus 1 times d. Now, that's technically a formula. You could leave it like that. Depending on the way it tells you that you need to put it into your homework, though, you may need to multiply that out. So that would be a sub n equals -4 plus 7n minus 7. And when you combine like terms, a sub n would be 7n minus 11. Again, both answers, but if you're told to simplify, then you need to go all the way to the one there in the box. Okay, so that's step A, find the nth term, which is again what that a sub n is. Now find the 20th term, that's going to be find a sub 20. And in this case, that means that your n is 20. So a sub 20 is going to be 7 times 20 minus 11. I'm going to want to see that step. Now that's all you have to show me. You can go ahead and just give me the answer after that, but I want to see that you actually use the formula to find that. So a sub 20 is 129. Okay. Now, if you were asked to find the fifth term in an arithmetic sequence, again, if they give you the equation, you just plug 5 into that. That's probably actually pretty obvious based on what we just did there, but you may not necessarily have to find an equation first. They might give the equation to you. Okay. Last one here on the front, find the nth term of the sequence with a sub 5 equals 19 and a sub 9 equals 27. Okay, so the deal is here, I can't write this equation because I don't know the first term and I don't know the common difference. And if they were next to each other, that would be easy to figure out, but I've got the fifth term all the way to the ninth term. Now, you can do this a couple different ways. This is the way that they show you to do this in your book, and that's to create a system of equations. So here is the formula that I would use to find any particular term. In this case, I know the fifth term is 19. So n is 5, and a sub 5, is 19. So the first one would be 19 is equal to a sub 1 plus n minus, oh, sorry, not n. 19 is the fifth term, so I'm going to plug 5 in for that. Minus 1 times d. And I get 19 is equal to a sub 1 plus 4d. Okay, so that's an expression for the first situation. Okay, that was for this one right here. Okay, now, if we want to do one for this one, okay, that's going to be 27 is equal to a sub 1 plus 9 minus 1 times d. That's a 9 there. So we end up with 27 is equal to a sub 1 plus 8d. Okay. Well, now what I have is a system of equations, and we're going to be doing stuff, a bunch of stuff with that when we get to the next unit. I'm going to solve that system of equations. So over here, or underneath here, I'm going to write the 19 is equal to a sub 1 plus 4d. And then we're going to write underneath it the other one, 27 is equal to a sub 1 plus 4d. And I want to eliminate a variable here to solve this. Now, hold on, I wrote the wrong number down here because I'm looking at this thinking the whole thing is going to cancel out. Let's fix that. Okay, 8d. Now, what I'm going to do is I'm going to subtract the 2. Now, subtracting can be dangerous, so what actually might be better is if you rewrite this and change the signs. But if I were to add these and my a sub 1s were opposite, let's say, then that variable will cancel out. So look like this. 19 is equal to a sub 1 plus 4d. Negative 27 is equal to negative a sub 1 minus 8d. So when I add those together, I get a negative 8 is equal to negative 4d, and I end up with that d is 2. Sorry, d is 2. Okay. Now, in order to write an equation, I need d and I need a sub 1. So I have found d. Plug d back into either of these equations here to find your first term, and then we can plug them into the formula. So I'm not going to do the math for that, but if I do plug that back in, actually I'm going to write it over here. I get that a sub 1 is 11. Okay. So my equation now would be a sub n is equal to 11 plus n minus 1 times 2. Now, there are a variety of ways that you can do this type of question. You can use your slope to come up with your d, because in this arithmetic sequence you have a constant change from one term to the next. So just to kind of show you a heads up how that would work, if we think about these 2 points here as being, or those two terms as being 2 points, if you find the slope of those 2 points, your slope is 2. Okay, that happens to be the same thing as my d value. And then you can plug that d value back into a formula to find out what your, if you plug your d value in along with your fifth term, you can come up with that first term. Okay, so if that's something you think you're interested in looking at in more detail, let me know, and I'd be happy to show you that. But this is the way the book does it, and being that we're doing systems of equations in the next chapter, we thought this would be a good way to go about doing this one. This should also be, if you do the show me's, that should be how it's done in your book. Okay, now the whole back page here is about sums of arithmetic sequences. Now, let me also kind of back up here. I know I told you here on the front, you will be given this formula right here, okay? And we're going to add to that. Here on the back, you will be given this formula right here. Now, this formula can be given to you in different forms. Sometimes you'll see, instead of n over 2, you'll see the whole thing divided by 2, because you can write it either way. But this is not a formula that you'll have to memorize, but you'll have to know what it's for. Okay, the s sub n means sum. The n over 2, the n is still your number of the terms. So if you want to add up 5 terms, then your n is going to be 5. A sub 1 is your first term, and A sub n is your last term. So if you're adding up 5 terms, then A sub 5 would be your fifth term. Okay, so let's say we want to find the sum of the first 9 terms in a sequence. Okay, in this context here, you would assume that the 9th term is negative 24. Otherwise, this question would be pretty difficult to do. So S sub 9, which means the sum of the first 9 terms, is equal to 9 over 2. 6 plus negative 24. Now, as far as work, that's all I really need you to show me. If you want to show more, that's fine. That would be 4.5 times negative 18, and that would be negative 81. Now, before you walk away from that problem, look to see, does that make sense? If you end up with a negative, but none of the numbers in your sequence are a negative, then no, that does not make sense. In this case, it might be hard to tell if that makes sense because it seems kind of big when all you have is a negative 24, but there were other negative numbers leading up to that, so that makes sense. Okay. Now, the next one here wants me to find the 8th partial sum, which means the sum of the first 8 numbers of the sequence 5, 8, 11. Now, using that formula, I need to know how many numbers am I adding up. Well, that's going to be 8 because it's an 8th partial sum. I need to know the first term, which would be 5, but I don't know what the 8th term is, so I have to find that one first. Now, I have a formula to do that. In my formula, I'm going to rewrite that up here. A sub n is equal to A sub 1 plus n minus 1 times d. Okay, so A sub 8 would be A sub 1, 5, plus, I'm looking for the 8th term, 8 minus 1 times d. Okay, in this case, I'm adding 3 each time. That's going to give me 26. So now I know how many numbers I'm adding. That's 8. I know my first term. That was 5. And now I know my 8th term. That's 26. So S sub n is equal to 8 over 2 And again, that's going to be a sub 1 plus a sub 8. 8 over 2 is going to be 5 plus 26. So 4 times 31 is equal to 124. All right. Now, the next part here is a sigma notation. Now, this is something where you would be asked to show work on this, either that we're using a formula or that you're literally finding all 10 numbers and adding them together. In this case, though, if we know that it's an arithmetic sequence, we can use the formula, and that's going to save us time. This would be the type of a question on a test that I might ask you to find the sum of 1 to 50, just to prove to me that you don't have to do it by hand, because that's not what I'm intending. Okay, so in order to use the formula, and I'm going to rewrite it down here since we can't see it anymore, I need to know how many numbers am I adding up. I need to know the first term, and I need to know the last term. Okay, well, we're going from 1 to 10. So the first term is going to be my a sub 1. The last term is going to be a sub 10 because my sigma goes from 1 to 10. And then my n is going to be how many numbers I'm adding up. Now, if you go from 1 to 10, that's 10 numbers. Now, if the bottom number wasn't a 1, which could happen, then that means that you're not adding up 10 numbers. Let's say the bottom number was a 2. If you go from 2 to 10, that's only 9 numbers. So be careful about that assumption. On the test, I'm pretty sure that we're straightforward, and it's just going to be, if there's a 10 on the top, it's going to be 10 numbers. Okay, so my first term, a sub 1, would mean that my n is 1. So that's going to be 3 times 1 plus 1. That's going to be 4. My a sub 10, that's going to be 3 times 10 plus 1 is going to be 31. And like I said before, my n is going to be 10. I'm going from 1 all the way up to 10. That's 10 numbers. Okay, so S sub n is going to be 10 over 2. We're using the formula right here. My first term is 4 plus 31. It's a really common mistake, guys, to have that last number be a 10, but 10 is not my 10th number. 31 is my 10th number. Okay, so that's 5 times 35, and that's going to be 175. All right. Now, the last one here, if you were asked on the last question to use a formula, if you plug 1 in, plug 2 in, plug 3 in, plug 4 in, all that, all the way up to 10, and then add them up, you're not going to get very much credit for that. I actually want to see you do the formula. Okay, last one, we have a story problem. This is another big application-heavy unit. Each row of an auditorium has 2 more seats than the preceding row, which means the row before it. Find the seating capacity if the front row has 30 seats and the last row has 108 seats. Okay, so in this case, I know how many are in the first row, that's 30. I know how many are in the last row. If I'm finding the seating capacity, I'm finding the sum. So back up to this formula up there. All I don't know in this case is my n. I need to actually know how many rows are there. So in this case, I have to work backwards to figure out how many rows there are. So again, my a sub 1 is going to be 30. My a sub n is going to be 108. Now, I can't say right now that's a sub 10 or a sub 5 because I don't know that. And I do know that I've got 2 more seats as I go from row 1 up to the a sub n. Now, how do I know that I'm adding 2 and not subtracting 2? Well, look at what we just wrote down. If a sub 1 is 30 and I'm going to the last row, which is 108, I would have to be adding 2. Okay, so my a sub n is 108. My first term is 30. I don't know how many rows I have, but I know that my common difference is 2. Okay, so if we solve that, we end up with 78 is equal to 2 times n minus 1. You can either distribute the 2 or you can go ahead and divide, however you want to do that. I'm going to go ahead and distribute the 2. So 78 is equal to 2n minus 2. So 80 is equal to 2n, and n is equal to 40. Now that I know that, now I have everything that I need to be able to find the sum. So I don't really need to rewrite this again here, but there's my formula. Okay, so 40 over 2, 30 plus 108. That's going to give me, once I do all the math there, 2,760 seats. Does that make sense? Well, that may not be obvious from this question, but yeah, I mean, there would be a lot of seats in an auditorium. So as we continue adding those rows, I'm going to have a lot of seats in them. So it does make sense in this context. Big thing on this is make sure that you're using formulas whenever possible. I know that I could have you figure this out another way, reasoning it out, but that way is going to be less efficient. I need to see you use these formulas. Okay. Now, the next lesson is the last one. We're going to do the same kind of things, but the next lesson we're going to be multiplying by the same thing each time.